Please welcome Hanjo with his talk, How the Cloud Changed the Way I Do Analytics and Research.
Okie dokie. I think everything's working. Okay, so good day everyone. As introduced, my name is Hanjo Odendaal, and I'll be speaking about sort of scalable analytics. I've been working on a lot over the past few months with H2O, and especially utilizing AWS, and it's opened up sort of a whole new sort of set of tools that I can use to accomplish some of the sort of research that I'm currently doing. So I'm not inhibited by my machine, so I can design much better experiments. Okay, so just to start off with, I think if you haven't played with AWS, there's only one goal for you today, and that is to actually go register, go out there, take 100 Rand, spin up one of these big R4 16x large machines. They're about 64 cores, half a terabyte of RAM, and for $100 you can light that sucker up for 10 hours if you've got like parallel while loops of random forests, and that's quite entertaining. So if you ever have one goal, that's what you want to get from this talk today. Okay, so I think we need to step back a bit, so I started 4 years ago, and I love Carrot. It's like one of those packages where once you get the hang of the general API, you fall in love. So why did I change? And in all honesty, there's a sort of in 2015 there was this kind of whispers of this new framework that was coming out called H2O. And the reason why I knew about it was because of Trevor Hasty was one of their lead consultants, and I'm sure most of you know who Trevor Hasty is. So I had to start checking this out, and then I played with it a bit, but it didn't feel that much art to me. I struggled a bit, and then came this talk in 2017 by a man named Slizard Pafka, and if you've never heard of this guy, he gave, I think, one of the most brilliant talks I've ever listened to in my life, and it was called No Bullshit Data Science. And he was speaking about sort of, don't believe the hype around industry. The newest, latest deep learning model is not going to fix your problem. A normal random forest or linear regressions may be what you want. So, I highly recommend you go watch that talk. And I think the other really interesting thing that I enjoyed from him was he was talking about this idea of you shouldn't be fighting your tools. It should feel natural, and you should be able to conduct analysis in a state of flow. You mustn't run a model and then suddenly this error comes back that says error nominal training flow. I don't know if you've got that in Carrot, but it means absolutely nothing. Suddenly you don't know if there's an NA, or you just don't know. So my advice for you is, if you're really interested in machine learning, stop fooling around. There's two models, random forest and extreme gradient boosting. They do really well, and they do well at scale. So go learn the maths behind them. So these are really interesting graphs that he did experiments of scalability. So I'm sorry to hate on Spark, but that's Spark, and this is log scales, by the way. So Spark really struggled. Apparently there was a bug that I think they fixed it since. Let's hate on Python a bit. So Python crashed. This was R. So R scales linearly, which was quite interesting, so the bigger data set, the time it'll just take. And then you've got these low-level guys like XGBoost over here, and this was H2O. And as you can see, that it's not a one-to-one scaling. So the bigger your data gets is not that the time will just increase by the same factor. And that really took me back when I saw these kind of graphs. You also did this, and it showed that, unfortunately, this is R lacked a bit. But once you get to 100,000 or 10,000 rows, then R's back in the game. But it showed that these models actually, they scale well while keeping accuracy. And that was also, I think, some of the other problems is that as soon as you get much bigger data set, errors start creeping in with memory leakage and so on. So, what is this H2O thing? If you've never heard of it, so H2O is what they call a leading open source platform for machine learning. It's got multiple APIs, so whether you're coding in Java or Python, Excel, I didn't know that, and Tableau. Yeah, Excel and HO, that was new for me. And it's got really well-developed interfaces for GPUs. I don't know if you've tried to set up a GPU from scratch on an Ubuntu machine. It's like the worst thing in the world. I couldn't get it to work after 4 hours and 6 beers. Just couldn't get it to work. So, and I found H2O, there's a little flag, and you do the little flag, and then suddenly your thing's just running on GPU. So that's quite nice. The other big thing is, so H2O was really awesome, right? But in my work, I don't have big machines. We're a startup company. The biggest laptop in the office is my laptop, and it's a gaming laptop. It's got 16 gigs of RAM, 4 cores, so that's a big laptop. So I had this H2O, this big Canon, but I couldn't take it anywhere. So I went to the cloud. So AWS, I'm not sponsored by them or anything. Whatever I say here, Google can do the same, I think. But they've got these things called spot instances, which is awesome because you're actually buying a machine like that big machine earlier at 80 or 90% discount. So you don't need this machine all the time. You're not going to be running your model 24 hours, 7 days a week. You need it for 5 hours. You need a big machine. So, so these two tools they've enabled me not to just be sort of, better flow of data science, but it's allowed me to become a better R engineer. I had more time to build systems because these things just worked. Okay, so just a quick thing. 80% of my research is still in Carrot because it's a great framework for exploration, but H2O and live systems because they've got really nice logging and everything. So you're asking yourself probably, so where do you start? So you've never heard of these things before. Start with H2O. It's really high-level functions. It scales nicely, and the code interface smells good. You just read, some of the examples, and you understand what's going on. And also, I wrote a series of blog posts. So if you, have never heard of it from AWS, you can actually follow from part 1 to part 3, which is how to set up an AWS account. Welcome to Per and Fur and things. To actually running basically the same demo I'll be running in a small bit. And the amazing thing is if you combine this with this Fur package, things start really getting exciting. So, and there's no excuse to not play. A machine that's bigger than my laptop is 50 cents an hour. So, that's nothing. And like I said, those big machines is 9 Rand, 10 Rand an hour. So, so there's no excuse for you to be oh, cloud computing is expensive, I'm not allowed to do it. It's a nice place to experiment. And what's nice about these sort of cloud interfaces is if you screw up, you just kill that machine, spin it up again. It takes you 30 seconds, and then the machine's back up. Okay, so the other thing I like about H2O is if you like sort of the maths and stats side and you're trying to really tune these models, this is what you have to your, okay, you can't even see it, but actually there's more tuning parameters. So you can tune these models extensively. So I really enjoy that. So let me show you a quick Hello World example of H2O. So I usually use H2O ensemble for the ensemble methods as well. So unlike sort of Carrot and so on, you need to initialize this Java server. So here I'm initializing H2O server. I'm saying, okay, you can have 500 gigs of RAM because that's sort of what I have available. I'm doing nothing else with the server. And I'm going to use 500 gigs of RAM to predict iris, as one does. And then you have to transform it into hex. So these are actually part of the key of why H2O is good. So this is that HDFS format that was talked about in the previous session, or the previous talk, and that makes it really fast as well. So, okay, so I'm going to tune this model. Okay, but when I initialize, you get a nice sort of information section over here that tells you, well, we've got 64 cores, that's how much RAM you have, and that means, okay, you can run the model. So running the model entails sort of, okay, so I'm running the section over here, and it says, okay, I'm loading up to the server, and then I'm completing it. So I also enjoy the fact that you've got some nice progress logs, which is really nice. The other thing that I really enjoyed about H2O was it had good logging. So I could, like extensive logging. So whenever something went wrong, I could just go into my logs and it'll tell me like, oh, so I could actually see, it tells you a little bit about each of the variables you're using, the cardinality is in there, and I haven't shown it here, but when it starts training the tree, it gives you log information for every tree built. So if the tree died, maybe at 136, you can actually see why that specific tree died. And then, as I said earlier, fur never looks so good. So it's really nice if you have this like machine learning models and this framework available to you, but you need to be able to utilize this sort of I can say sort of the scalability with a big machine. And to do this, you can use fur. It's a little stranger, but the start instance function is actually just something like I wrote a little wrapper for that actually uses reticulate and Boto3 to spin up an instance. Then I get the information from that instance, and I connect to it using the future or this future package, and I actually make a cluster from that. So if you've ever done parallel computing in R, you'll recognize this make cluster command. And that essentially says, okay, go spin up these workers for me that's going to do my analytics. So without further ado, I actually want to show you an example. So with all the things that's happened today, we're really hoping that this works. Okay, so let's see. Okay, so what I have here, let me just have a look. Okay. Sorry, it's obviously not so happy today. Okay, so this is a small server of mine that I play with on the side. So to give you an idea, this server has a total of maybe 2 gigs of RAM and a total of 2 cores. So this is my little server. Oh, you can't see, sorry. All nice and red there. But anyway, this is H-top. So I've got 2 cores running on this server, and like I said, about 2 gigs of RAM. Now, I don't know about you, but that's not the kind of machine you're used to doing any analytics on. So what I'm going to do is, the red doesn't come through here. Sorry, I want to just start this up quickly on my side. So what I'm doing is, I've got a little script, and that script, you can actually see what it does. If sorry, I'm just going to put the sound off. There you go. So, there you go. Okay, so this little script. Okay, yeah, I can do that. Oi. Okay, I think I've got time to quickly do this. Sorry, I need to quickly go into PuTTY because apparently some of you can't see. But I'll come back to this because I want to start this process off. So essentially, I've written a script that's now going to train for me a random forest model. 5. Okay, so there it's going to start. So essentially, what I want to do is I want to train on the Higgs boson data set, and I want to predict that data set. And I want to use a gradient boosting model, and I want to use a random forest model, and I want to bootstrap that model 5 times while doing 5-fold cross-validation. My little machine is not going to use that, or not going to be able to do that. So what I'm doing is, I'm going to do this. So what I'm actually doing is, I'm connecting to AWS. There you go. Anytime now. And now what you've seen is that little script has gone. It's initialized for me 5 machines. So what I've done is I've paralleled a kickoff of machines of training of bootstrapping these models for me, even though I only have 2 cores. So that's been like future map does this for you. You just tell it, I want 5 workers. So what we do see here is this is the workers sort of running in parallel, predicting my Higgs boson dataset. So how do these scripts look? So to give you an idea, this is sort of the basics of the script. So this is familiar to you. You'll be able to, you'll know about train and so on. But then this is where the beauty of it all starts. Is you can run use this process called plan if you've never used fir, and that will give you a multiple process instance. And I'm actually running this mutate over parallel. So I'm doing a future map saying, please do this 5 times, conduct the simulation run for me. So my little machine is hasn't done much, right? All it does is it said, initialize these instances, go train these models for me. And when the results are ready, bring them back. So I think, I wonder if I can do this on the fly. Okay, I won't be able to do this on the fly. So let me show you sort of how I built this up. So, like I said, this is going to look a little bit intimidating, but if you follow that little blog post that I wrote, you'll see why I do some of these things. So this is me. I've got a function here that says, well, generate some config for me. There it's importing the Botto library from Python. I'm starting up this instance. I'm using the start instance one command that I wrote that looks like this. So it's a little EC2 object, and I say, please request this for me using this image, this security group, and my key name. And then that's the one that kicks off those little workers. So let me just have a look here. Okay, so there, if you look on the sides, unfortunately, sorry guys, you can see that now what it's starting to happen is the servers are starting to close. Okay, I've still got connection, I think. So what it's doing is it's actually now closing these connections for me. So if I refresh over here, okay, so only 2 of them are still running. Okay, so there's the 4th one. So it's closing that connection for me. And then in a short while, we should see the last one. So let's just make sure. So yeah, you've got to make sure your instances do close, because otherwise the build does actually start adding up. Okay, let's give it 2 more seconds. Maybe I can show you one more command while this thing, while it closes up. So there's a cluster terminate instance. And then I want to show you maybe the meat of the function is, if I go in here, so this is the meat of the function. So essentially I'm starting up my server. I'm saying if there's any problem on exit, terminate the cluster in any case, please log this information for me so I can follow up, connect to that cluster for me, and then I'm sending the cluster the information and conducting it. So starting to train, again, future map. So whenever you're working on a cluster, and any command needs to happen on the cluster, you have to use future map. That entails for everything, because the data is actually not on your server, it's on the other server. So I map it, and I get the log loss. So let's just have a look here. And okay, so there you go. So if you see now, if you go look on the side screens, you can see that what I've done is I've essentially, there's my logging, so I can log the information of which IPs I've used, how many cores, and there you go. So there you can see I've trained a gradient boosting model 5 times with 5-fold cross validation. So I've bootstrapped these models. There's my RF model, and this all happened on a 2-core machine with less than 2 gigs of RAM. So I don't need big servers anymore. I can actually just use these tools that's being provided to me to actually conduct my analysis. And that is it. Thank you very much.